countries. These systems use advanced algorithms to analyze data continuously. In one case, an AI system analyzed data from sensors installed on a dam. It detected unusual vibrations that were not visible to the naked eye. This early warning allowed engineers to reinforce the dam's structure, preventing a potential collapse. The timely intervention was crucial in averting disaster. In another case, AI helped optimize water releases from a dam during a heavy rainfall period. The system calculated the best times to release water to minimize risk. This prevented flooding downstream while ensuring the dam's safety. The AI's predictive capabilities were instrumental in managing the water flow. These examples showcase AI's potential to save lives, protect infrastructure, and prevent economic losses. The future of dam safety is being reshaped by these intelligent systems. Section 5. Challenges and the path forward. While AI offers significant benefits, challenges remain in its widespread adoption for dam safety. These challenges are multifaceted and require a concerted effort to address. Data availability. AI algorithms require large data sets for training and validation. Without sufficient data, the accuracy and reliability of AI systems can be compromised. Obtaining high-quality data from dams can be challenging. Factors such as the age of the dam, the type of sensors used, and environmental conditions can all impact data quality. Cost implementing AI systems can be expensive, especially for older dams that lack modern monitoring infrastructure. Upgrading these systems requires significant investment, trust, and acceptance. There might be resistance to relying on AI systems for critical infrastructure safety due to unfamiliarity or concerns about job displacement. Building trust is essential. Despite these challenges, the benefits of AI for dam safety far outweigh the drawbacks. AI can provide real-time monitoring and predictive analytics that are invaluable. We need to invest in research and development to overcome the limitations and make AI more accessible. Collaboration between industry, academia, and government is crucial. We must also develop standards and regulations to ensure responsible and ethical use of AI in dam safety applications. These guidelines will help in maintaining public trust. In conclusion, AI is revolutionizing dam safety by enhancing monitoring, risk assessment, and decision-making. It offers a proactive approach to managing dam infrastructure. AI is not a replacement for human expertise, but a powerful tool that augments our capabilities. It allows engineers to focus on more complex and critical tasks. By embracing AI, we can build a future where dams are safer, more resilient, and continue to provide essential services to communities worldwide. The path forward is clear, and the potential is immense.